All right, in this video we're going to look at radian measure of an angle and how we can find that, how we can convert from degrees to radians and back and forth, and how we can use this new and different way to measure angles. Let's check it out. So by now you're probably familiar about how to measure an angle, what an angle is. If we take two rays, here we have a ray, here we have a ray, and we measure the fraction of a turn in between those two rays, that's the angle. And we know that if we make a full turn or we go all the way around a circle, well, in degrees we define that as 360 degrees. So we know 360 degrees is one circle. All right, one turn. All right, one full arc. And where this number came from, there's different ideas. There's a possibility it came from ancient calendars that had 360 days, a full turn around the sun. But wherever it came from, that's a standard way to measure angles. And if we break up that turn, a part of a turn, well, it might be 30 degrees. And so this would be like 1/12 of a turn to get 30 degrees. Okay? Well, another way that we're going to look at has to do with the arc length of a circle. And 360 just is some arbitrary number, so we would like a different way that has to do with length so that we can get a more useful number. And if we talk about the distance around a circle, we call that the circumference. And we know that if we have the radius of a circle, which is in this case, let's say it's 1 foot, we know that we can use the formula as circumference equals 2 times pi times the radius. And so if we have a 1 foot circle with a radius of 1 foot like we're looking at here, then we have 2 times pi times 1, which is just 2 pi. And we'll say this is feet. So imagine we've got some circle here, 1 unit, 1 foot, whatever it might be. The circumference is 2 pi. All right. So we've got this circle with a circumference of 2 pi. And we want to find out what fraction of a turn this is. How far is it if we got a little ant that starts here at point A and he wants to walk up here to point B? What is that distance around this curve? Well, if this is a 30-degree arc, then we can say this, that arc length, let's call this S. That arc length is just a fraction of the turn all the way around the circle. So that's 30 out of 360. And so 30, and that's a fraction of the whole circle. The whole circle is 2 pi. All right, so if we want to go all the way around the circle here, if we want to travel from here and go all the way around the circle, we're going to have to travel 2 pi units or 2 pi feet in this example. Okay, if we just want to go a fraction of the turn from A to B, then we're going to go 33/60ths of that. And if we clean that up here, then we have, that's just 1/12 times 2 pi, which is, think of this as a fraction if you want, 2 pi over 12. And simplifying, we get pi over 6. And that would be feet in this example. All right? This distance here is pi over 6 right here. All right. So this distance right here is pi over 6. All right. So since that's a 30 degrees, well, this one must also be pi over 6 here. Okay. If we were to look at both of these together, we'd have 2 times pi over 6 would give us this total length here. And this is how we're going to define radian measure. If we have a 1 foot circle, it turns out that whatever this arc length is, be it pi over 6 or even 2 pi over 6 for this whole angle. Whatever that arc length is, that is the arc measure. Or another way to define that is this. If we take this radius of 1 foot and we were to take and find another radius, we would find a length right here. That's 1 foot. That angle right there, this angle right here, would be 1 radian. So this would be a 1 radian angle, because the arc length is 1 foot. Okay. If we have an angle that cuts off pi over 6, then this would be a pi over 6 radian angle. Okay. And this angle right here is another pi over 6 radian angle. Okay. So we end up with two ways here to measure or to define radian measure. The standard definition that you'll see in most textbooks is that a radian measure, 1 radian, is the measure of an angle that intercepts an arc that is the same length as the radius. So that's this right here. So this is a 1 radian angle. If we take our radius 1 foot, we wrap it around the circle, then that would give us this angle of 1 radian. But another way that seems to be useful for a lot of people is to think about this angle in radians is just the length of the arc in our unit circle. This is a unit circle, 1 foot or 1 unit. So that arc length is the radian measure. So that's the key. Radian measure is an arc length. And as we go on now, and we're going to look at some conversions here, keep in mind that we have an important measurement. This angle, if we go halfway around a circle here, now that's a 180-degree angle. So this angle right here would be, so if we take this angle, make it a little different color here. Let's go like this. All right, so if we take this angle here and we get a 180-degree angle, well, the radian measure of that, this length right here, is half the circumference. We know the circumference is 2 pi, so this length is 1 pi, and so that angle of 180 degrees is going to be equal to 1 pi radian. And that's going to be an important relationship, okay? Because remember, again, the radian measure is just the arc length on this unit circle. So with that in mind, knowing that we have 180 degrees is 1 radian, or 1 pi radian, sorry about that, 180 degrees is 1 pi radian, then we can make some conversions here. And so we have some conversion factors. Since 180 degrees and pi radians are the same, this fraction here is worth 1. So if we're going to convert from radians to degrees, we multiply by this fraction. We want to convert from degrees to radians, we're going to flip it around. All right? So let's see how that works. Here we have some questions. We've got 120 degrees. We want to convert that to radians. All right? Well, up here, if we want to convert degrees to radians, so that's the second one, we're going to multiply by pi radians, which we'll abbreviate rad, divided by 180 degrees. And what's really going on, this is what we call dimensional analysis. These degrees on top and these degrees on bottom are going to kind of cancel. And so that kind of tells us that, yes, we multiply by the right fraction, and we get 120 pi over 180. And the units that are left are radians, so our units here are clearly radians. Okay, now we want to clean that fraction up a little bit, and so let's see what goes in. 60 goes into 120 and 180, and so that's going to be 2 pi over 3, and that's radians. All right. So there we have our conversion. Now we're going to do some cross-canceling rather than multiplying and doing this. We can do some canceling ahead of time, and we could have gone back here and said, oh yeah, 60 goes in there 3 times, 60 goes in there 2 times, and that would lead us right to our answer. All right, let's try a couple more here. So what if we have degrees and minutes here? So a minute is a way to measure an angle. That's a fraction of an angle. It's 1/60th of a degree. So we know that a degree, there's 360 in a circle, and so this is just 10 and 45/60ths, okay, of a degree, or 10 and 3/4 degrees. These are degrees. Or actually, let's go ahead and make this an improper fraction, and we're going to get 43/4 degrees. All right, so we could make this a decimal if we wanted to, if it wasn't so nice a fraction, but let's go ahead and try this. So we have 43/4 degrees, and let's go ahead and multiply this by our conversion factor. We have pi radians, which is equal to 180 degrees. All right, and so the degrees kind of cancel here once again. And it doesn't look like there's going to be any canceling. There's no common factors for 43 and 180. You can't cancel this way. So it's just going to be a nice ugly 43 pi over 4 times 180, which should give us 72. And that's radians. All right, converting the other way now, we have 2 pi over 9 radians. And actually, let's go ahead and put, you might want to think about the radians as up top in this fraction, because now we're going to multiply by 180 degrees over pi radians. And again, these units here will cancel because we got radians up top, radians on bottom. And what else will cancel? Let's see, we've got this pi, and this pi will cancel. And 9 goes into 9 once, 9 goes into here 20 times. So rather than multiplying and then canceling it, it's nice to do it first. And we're left with 2, this all cancels, times 20 on top. And so that is 40. And we're still left with the degrees up top. And then 1 times, well, we should have left some 1s behind here, a 1 behind. There. All right, and there's our answer, 40 degrees. Last but not least, a radian measure does not always have to have a pi in it. So what if we have 2 radians? Okay. Well, our conversion is still 180 degrees over pi radians. And the radians, again, will cancel here, like a little dimensional analysis. And, well, does anything cancel here? Does 2 and pi cancel? No, they don't. So, best we can say is go ahead and multiply this up. 2 times 180 is 360. And on bottom we have pi. So we have 360 over pi degrees. All right. Maybe we'll put some parentheses around here. All right, so that's how we convert back and forth. Again, the key relationship here, 180 degrees and 1 pi radians are the same. And that, again, comes from the fact that radian measure is just the length of the intercepted arc of this unit circle. All right, well, good luck and have fun converting.